Okay, so we'll be now learning about how you're going to be lighting up your first LED, right? So to light up your LED, you're obviously going to need your LED and some voltage source. You're also going to need another component, but that will come later. Okay, so the battery we have is a 9-volt battery, right? And we have an LED. Okay, now LEDs are polarized. What does that mean? What does polarization mean? Polarization means that they can only be connected in the circuit in a certain manner. So that means for LEDs, the way to indicate or the way to know how they're going to be wired is basically knowing that the longer lead is always going to be visibly longer. The longer lead is always going to be the more plus side, and the shorter lead is always going to be the more negative side. So basically, whenever you're wanting to power up the LED, you're going to connect the negative to the negative, right? And then you're going to connect the positive to the positive. But here's the problem. If you do this, you'll end up burning up your LED. And that should happen because the LED is not rated for 9 volts. The LED is actually only rated for 3 volts. That means it requires 3 volts to be across it, and it needs 20 milliamperes flowing through it. These are the specifications of the LED. These are generally what an LED demands from you. So it needs only 3 volts across it and 20 milliamperes flowing through it. But what do you have? You have 9 volts across the LED. That's definitely why the LED keeps on burning up and exploding, because you're putting a higher voltage across what it really actually demands, right? And the excess of anything really ends up destroying something. So how are we going to tackle it? We're going to tackle it using a resistor. So like we learned in the water analogy, a resistor will limit the current no matter what your pump is. So basically, we're going to put in a resistor into the circuit, right? And now what you really want to do is we need to calculate the value of this resistance. And this is where Ohm's law comes in, right? Okay, so you've got a total of 9 volts. You have got 3 volts across the LED, right? So that basically means you'll have to have a drop of 6 volts across the resistor that you're going to use, right? You're going to have a 6 volts drop across the resistor. Then the second thing, this whole circuit, the current that will be flowing through the whole circuit will be 20 milliamperes. So the voltage is going to be this, and the current that's going to be flowing through this resistance is going to be 20 milliamperes, which the LED is going to demand. That's what we're basically wanting to calculate. We want the resistor to limit the current to only 20 milliamperes and have a drop of 6 volts across it. And now you can basically use V equals to IR, Ohm's law. You know that across the resistor, I want 6 volts and I want 20 milliamperes flowing through it. 20 milliamperes can be written as this, 20 divided by 1,000. And then the resistance is going to be what you're going to calculate. And once you're going to calculate this resistance, it is going to work out to be a 300 ohms. So this is how we're going to be lighting up our first LED. We're going to have a battery. We're going to connect a resistor to the LED and then basically take its negative pin back to the ground. Right? That's how we're going to be going about our first circuit.